concept of selective use of exogenous idiotypic and anti-idiotypic antibodies for the correction of immune processes during the treatment of diseases. Panalig, PANAcea, Lacto, Immuno, Globulin. Innate immunity or non-specific immunity is the natural resistance with which a person is born. It provides resistance through several physical, chemical, and cellular approaches. Adaptive immunity is often subdivided into two major types depending on how the immunity was introduced. Naturally acquired immunity occurs through contact with a disease-causing agent when the contact was not deliberate, whereas artificially acquired immunity develops only through deliberate actions as vaccination. The other type of immunity is being the adaptive immune system, the body's ability to neutralize foreign and potentially dangerous microorganisms or toxic molecules that have already entered the body earlier. It is the result of the work of a system of highly specialized cells, lymphocytes, located throughout the body. In any case, immunity is the only system for protecting the body from external and internal pathological factors. The immune system is absolutely independent and so autonomous that its action is in no way subject to the body. Sometimes reactions of the immune systems cause serious harm to health, autoimmune diseases, and can be fatal. However, it is possible to control the activity of the immune system and the direction of its action, changing the number of only those immune cells that are associated with the manifestation of undesirable or conversely necessary reactions. All manifestations of immunity are realized by immunocompetent cells and serum humoral factors. 1. Immunocompetent cells. A. Macrophages. T. Leukocytes. B. Leukocytes. 2. Humoral factors. Antibodies. Immunoglobulins, Ig, of the classes IgA, IgD, IgE, IgG, and IgM. B. Complement, the main factor of the body's immune defense, a natural component of blood serum. The cause and the main participant in immune reactions is the antigen. An antigen is any substance, biological or man-made, capable of causing immune responses. Depending on the complexity of the structure, an antigen can have one or more immunogenic sites, determinants. Macrophages can distinguish immunogenic antigen regions from the body's own structures and promote both the formation of antigen-specific receptors in T lymphocytes and stimulate the synthesis of antibodies by B lymphocytes. Macrophage recognizes the antigen and informs about the T and B lymphocytes precursor cells. Having received information from the macrophage, the T cells proliferate, forming a clone of T lymphocytes with receptors for only one immunogen. The information from the macrophage from the B cells uses to form a clone of B lymphocytes, producing antibodies of the same specificity, directed against only one immunogenic site and of the antigen. T lymphocytes are capable of direct contact and interaction only with those cells' antigens to which they have specific receptors. Humoral reactions involve antigen-specific antibodies that disturb antigen functions. This usually happens remotely, at a great distance from B lymphocytes, producing specific immunoglobulins. In humans, like other mammals, there are 5 classes of immunoglobulins: IgA, IgD, IgE, IgG, and IgM. In other animal species, from 3 to 6 types of antibodies have been found. The most studied antibodies are IgG and IgM. The Only immunoglobulins of the IgG and IgM class can interact with the complement. IgG, the only class of immunoglobulins that can cross the blood-brain barrier and cross the placenta. The amino acid composition of the light and heavy chains of immunoglobulins is genetically determined. There are specific genes for them. The variable regions of the light and heavy chains are not genetically determined, and their amino acid composition changes depending on the structural features of the immunogenic regions of the antigen. With the introduction of hexagenous immunoglobulins into the body of the recipient, the cells of his immune systems begin to synthesize antibodies and T receptors against heavy and light chains of molecule Fc-, FAB1, and FAB2 fragments, and its antigen binding sites. Own antibodies are also immunogenic for organisms, but its own immune system recognizes, matches only those regions of FAB1 and FAB2 fragments which bind the antigen, since they are genetically are not deterministic, in contrast to Fc- fragments, and by virtue of this are alien. To these sites of antibodies, anti-idiotypic anti-antibodies and anti-idiotype cellular receptors of T lymphocytes. The selectivity of antibodies is so great that they are able to distinguish between protein molecules differing in composition by one amino acid, human antibodies to porcine insulin, and even isomers of chemical compounds. The specificity of immunoglobulins is due to both the amino acid composition and the spatial organization of the antigen binding centers of FAB fragments of antibodies, which vary significantly depending on the properties of the immunogenic regions of the antigen. It is believed that the antigen binding sites of FAB- fragments represent a cavity, that the shape corresponds to the shape of the antigenic sites of the immunogen antigenic determinant. In this regard, it becomes incomprehensible how can interact with each other antigen binding areas of antibody molecules and specific antibodies to them. Cavity with the cavity? According to the Le Chatelier principle, the driving force for the interaction of the antibody with the antigen is the difference in the potentials of charged radicals on the part of both molecules. And the specificity, selectivity of antibodies, in fact, is the process of neutralization of charged antigen radicals by opposite, complementarily located in the space antibody charges. The more the charges of the molecules are complementary to each other, the higher the specificity and selectivity in the antigen-antibody reaction. So antigen-specific antibody is a complete antipode according to the science of charges of amino acid radicals, with the exemption of hydrophobic residues which interact with each other by the van der Waals forces. An analysis of the specificities of antibodies during sequential immunization of rats with them showed that the all odd 1, 3, 5 in order antibodies exhibit an affinity for the antigen, and even 2, 4, 6 anti-adipic immunoglobulins are able to neutralize odd 1, 3, 5 antibodies and accordingly participate in the destruction of clones of T and B lymphocyte cells that produce receptors and antibodies against the antigen. In turn, odd 1, 3, 5 antibodies fight both antigen and even antibodies and clones of T and B leukocyte cells that produce these antibodies and receptors. It is known that the maximum concentrations of antibodies, odd antibodies, to an antigen is reached by the 7th day from the ingress of the antigen into the body. The maximum concentration of antibodies even occurs by the 14th day. It is known that odd antibodies and receptors of clones of T and B cells of the leukocytes tend to eliminate the antigen and thereby stop the course of the pathological process. Even antibodies and receptors of T and B cell clones of their producing leukocytes stand guard of the antigen and aggravate the cause of the pathology. These can explain the rejection of transplanted organs, the deterioration of the patient's conditions noted in the clinical practice at 14th, 18th, etc. days. In clinical immunology, T lymphocytes that fight against antigen and against the development of pathology are called helpers and are referred to as CD4. Lymphocytes standing on the sides of the antigen and enhancing their pathology are called suppressors and are referred as CD8. The CD4-CD8 ratio makes it possible to judge the direction of the pathological process to attenuation or its development. The founder of the understanding that own antibodies can be immunogenic for the body was an outstanding immunologist, Niels Kajerne. His ideas about the simultaneous presence of clones in the body cells and antibodies fighting each other he published in 1976 in the form of the network theory, for which in 1984 he was awarded the Nobel Prize. Any immune process occurs with the participation of the idiotypic antibodies and clones T1 and B1 lymphocytes on the one hand and anti-idiotypic antibodies and antagonistic products, clones of the anti-idiotypic receptors and the antibodies T2 and B2 lymphocytes on the other. The Le Chatelier equilibrium in the immune process can be disturbed if the participants of the immune reactions are added or removed from the scale. Medicine has been using this technique for more than 100 years, using serums that shift the course of the pathological process in the right direction. The sera contain idiotypic antibodies against the pathogen antigen. The use of the anti-idiotypic antibodies for practical purposes of medicine so far extremely limited. Anti-idiotypic vaccines. The normal CD4-CD8 ratio is usually close to 1. A small plus or small minus to this value reflects a cyclical process of disruption and restoration of the balance between antibodies and clones of T and B cells fighting with each other. The detection of antibodies to tissues of various organs, lungs, liver, intestines, heart, etc., in the blood serum of sick patients is of great diagnostic value. This suggests that the balance between antibodies and antibodies is disturbed in the body in favor of anti-tissue antibodies. It follows from this that the content of tissue anti-idiotypic antibodies is reduced to this tissue and that this tissue, this origin, is at serious risk of autoimmune aggression. It is possible to remove such a risk or significantly reduce it by introducing tissue anti-idiotypic antibodies into the patient's body. However, this approach so far is not even discussed by immunologists. The use of tissue anti-idiotypic antibodies as an immunocorrector, in our opinion, could be a therapeutic method in the treatment of immune-dependent diseases, diabetes 2, allergies, rheumatism, arthritis, myocardial damage, neurological diseases, etc. Bringing to normal the general pool of normal immunoglobulins, both idiotypic and anti-idiotypic, including tissue, can restore the reactivity of the immune system lost with the course of pathology or with age. It is known that a common feature of all tumor cells, both benign and malignant, is a high rate of division compared to normal cells of the body. Any cell, including a tumor cell, cannot start dividing until it accumulates the required amount of polyunsaturated fatty acids, PUFA, which are necessary for building the walls of the daughter cell. The transport of PUFA to cells is carried out by alpha-fetoprotein AFP. On the cell surface there are special receptors, RE-AFP, for binding AFP loaded with PUFA. Normal cells, which rarely enter the division phase, have a small number of such receptors or do not have them at all. Tumor intensively dividing cells have an order of magnitude greater number of receptors on their surface, since they are dire need of PUFA. The phenomenon of antibody complement-dependent cytotoxicity is an universal mechanism that allows one to control the course of immune process in the body. The mechanism of selective lysis, which was previously shown for tumor cells, can be applied to cells of any T and B lymphocytes which determine the course of certain immune reaction. Cell receptors of the T lymphocytes are immunoglobulin molecules, presumably of the IgD class, permanently attached to the cell wall. By applying anti-idiotypic antibodies to such receptors, a clone of pathogenic T lymphocytes can be destroyed. Synthesis of an immunoglobulin molecule in a B lymphocyte cell takes several minutes, and its exit from the cell takes several hours. Thus, on the cell surface of the B lymphocyte, antibodies are present to varying degrees on the cell surface. They, if necessary, can also be a target for selective lysis of B cells. Anti-idiotypic antibodies to alpha-fetoprotein were used as an active substance of an immunomodulator drug Panalig. The drug interacts with any type of humour cells, regardless of their localization, species, or individual characteristics of the organism, which indicates the evolutionary commonality of cell division processes. The concept of using antibodies or anti-idiotypic antibodies to correct the reactivity of the immune system and control the direction of cause immune reaction allows you to create immunobiological drugs against any type of diseases that have the immune component in the pathology. On the basis of the concept of electrostatic interactions between antigen and antibody, the position of negative-positive correspondence of antibodies to antigen was substantiated, and the possibility of using anti-idiotypic antibodies for specific immunization instead of especially dangerous antigens was experimentally shown. Now it is called anti-idiotypic vaccines. In the work, traditional immunochemical rather than molecular biological research methods were used. The medicine has all previously theoretically predicted properties: absolute safety, multiple specific actions, and high therapeutic efficacy. Therapeutic effect of the medicine is not limited by a physiological status of a patient or a nature of a tumor cells or even their location. Thank you for your attention.